Okay, moving on to question number 2. Which of the following functions is or are continuous at x equals 1? Now there are 3 conditions that have to be met. There are 3 conditions that have to be met for us even to try this question. First condition, the limit as x approaches a of f of x has to exist. So it can't be like undefined, it can't be a number like infinity, it has to be just a normal number, a real number. Also, f of a has to exist. So when you plug the number directly into the function, it also has to exist. And finally, number 3, the limit as x approaches a of f of x has to equal f of a. So not only do 1 and 2 have to exist, they also have to equal each other. That's for something, this is the limit definition of continuity. The limit definition of continuity. Okay, so let's try that here. We want to know if we plug in 1 into this function, does f of 1 exist? Well, f of 1 would equal e to the 0 over 0, which is basically undefined. So it fails the second part. F of a does not exist. So this would be no. Alright, next part. G of x equals the natural log of x squared minus 1. Let's try g of 1. That would be the natural log of 1 minus 1, which is the natural log of 0, which does not exist. So no, it fails number 2 again. Still does not exist. Okay, how about h of 1? H of 1 is equal to sine of 1 over 1. And this is also the limit as x approaches 1 of h of x is equal to the same thing, sine of 1 over 1. So not only does it exist, the limit exists, the function exists, and they're equal to each other. So yes, this is continuous at x equals 1. Alright guys, moving on to number 3, we want to find dy dx, which is just the derivative for all of these functions. This is going to test all your derivative rules, and you have to know every single derivative rule. Okay, so I'm going to try and do the answers in blue and try and put the rules in red. If I see natural log of u, the weird thing about the natural log of u is that dx of ln of u is equal to 1 over u times u prime, or u prime over u, some people say. Okay, and also over here we're going to use the power rule. This is like x to some number, dx of x to the u is equal to x to the u minus 1 times u prime, the derivative of that power. Okay, actually, I'm sorry. That was totally wrong. That is derivative of x to the, I don't really want to do x to the u. I want to do x to the n in this case. Derivative of x to some number is x to the n minus 1 times n. We drop the n down and we decrease the power by 1. Okay, so let's actually answer this problem. We want y prime here. The derivative of the natural log of 5x is 1 over 5x times the derivative of 5x, which is 5, minus, well, this is the same thing as 9x to the negative 1. So this negative 1 comes down in front of the 9, so this is negative 9x to the negative 2. If I clean this up just a little bit, y prime, this 5 and 5 cancel, so we've got 1 over x plus 9 over x squared. Alright, for b, we're doing quotient rule. So the quotient rule, let's say we've got u over v, d dx of u over v. It's low, v, times derivative of the top, minus the top, times the derivative of the low, over low squared. So let's do that here. Y prime is equal to low times the derivative of the top minus the top times the derivative of the low over log squared. All right, I'm going to clean up the top just a little bit. We've got 3 times x plus 2, which is 3x plus 6, minus 3x minus 4, minus negative 4, so minus 3x minus negative 4, it becomes plus 4 over x plus 2 squared. And finally, the 3x's cancel, and we end up with 6 plus 4, 10 over x plus 2 squared. All right, let's move on to C. Here we have a function times another function. So I'm going to kind of do a quick recap of the product rule. If you have d dx of u times v, it's the first times the derivative of the second plus the second times the derivative of the first. Okay, let's do that here. So we've got the first, which is 3x squared plus 5, times the derivative of cosine of x. And the derivative of the cosine of x is negative sine of x, plus the second, cosine of x, times the derivative of the first. Derivative of 3x squared is 6x, times derivative of 5 is 0. So let's just plug it all in. Y prime. You can multiply this out if you want. You don't have to. In fact, I think it's easier. I'm going to write this up front. 6x cosine of x minus this product, which is going to be sine of x times 3x squared plus 5. That's the answer. All right, that's this answer. All right, this one is looking at a chain rule. Here, if you have a chain, so if you are trying to take d dx of a function within a function, you take the derivative of the outside, keep the inside the same, times it by the derivative of the inside. And in order to see that this is what this kind of a thing, we've got x cubed plus 7 to the 1/2 power. The 1/2 power is the outside function. Okay, so let's look at y prime. Outside function is something to the 1/2 power. Bring that 1/2 down. Inside stays the same. Outside, negative 1/2. Times that by g prime of x, the derivative of the inside. Derivative of x cubed is 3x squared. All right, put it all together. We have 3x squared up top. And we have 2 times the square root of x cubed plus 7 in the bottom. All right. In fact, I'm going to skip kind of right over this really quickly. I'm going to skip over E really quickly. I'll be come back. But F is really just demonstrating that rule. We've got F, and then g of x is inside it. So just following our rule that we just said right there, that's f prime of g of x times the derivative of g of x, which is g prime of x. All right, let's go back to E, because I skipped that one to begin with. There's no special rules that we haven't already covered, except we're going to want to make sure that we rewrite this so that this is in fact, I really like this squared. I want to recognize that that is another function. So I'm going to put that on the outside like this. I've got x to the 4/3. All right, we're going to go ahead and take the derivative of this. Y prime. Derivative of the outside is something squared. So the derivative is 2 times that something. Keep it the same. To a power of 1 less, which is 1. Now I can work on the inside. The inside is its own chain. We've got an outside and an inside. So the derivative of sine is the cosine. Keep the inside the same. Times the derivative of the inside, 6x, which is just 6. Plus the derivative of something to the 4/3, x to the 4/3. Bring that power down. Reduce the power by 1. So that would just be 1/3. If we put it all together, we've got a 2, we've got a 6, so we've got 12 sine 6x cosine 6x plus 4/3 x to the 1/3. Oop, there you go. All right, we did F. Let's skip over to G. We've got a product rule, t squared and sine of t. So y prime, this is a product, so it's t squared first times the derivative of the sine, which is cosine of t, plus the second, sine of t, times the derivative of t squared, which is 2t. You can't multiply these because this t is stuck inside the sine. So let's go ahead and just bring it right up to the front. I got t squared cosine of t plus 2t sine of t. All right, H. This is an arc sine. That -1, it doesn't mean 1 over, it means the arc sine. So hold on a second. Let me change back my colors. We had a rule that said d dx of the arc sine of u is equal to u prime over the square root of 1 minus u squared. So we're going to go ahead and do that. All right, arc sine of, here's our u. This is u right here. So y prime. We have u prime. What's the derivative of 3x? That's 3 over the square root of 1 minus u. That's 3x squared. Plus the derivative of tan of x. Tan of x is secant squared of x. And then this term all the way on the end, it says -1 over x cubed, which is really minus x to the -3. So if I bring that -3 down in front, it becomes plus 3x to the -4. So if I wanted to write that correctly, let's write it one more time down here. Y prime is equal to 3 over root 1 minus, I'm going to square this, 9x squared, plus secant squared of x, plus 3 over x to the 4th. All right, and last but not least, I. Just a little bit more complicated, same kind of stuff though. This is a constant multiple, so we can just keep it in our answer and take the derivative of the inside. Derivative of 2x cubed is going to be 6x squared. All right, we're going to use our arctan formula, which is just 1 over u prime over 1 plus u squared. So 5 times u prime, which is 2 over 1 plus u squared. Cleaning up a little bit, this becomes 30x squared plus 10 over 1 plus 4x squared.